All right, so allow me to apologize in advance for how clickety clackety that last video was. I did not realize it would pick up on my stylus so badly, so I put my headphones in and I hope it's better on this video. But thanks for sticking with me through the first one. So we just finished talking about homogeneous mixtures. So let's round that out. And now we're going to go over and talk about heterogeneous mixtures. So if homogeneous means the same throughout, then heterogeneous is going to mean different throughout. Okay, so if I have a heterogeneous mixture, I can take a sample from one place in the mixture versus a sample in the other place, and it will be made up um, maybe of the same things, but maybe in different proportions or something like that. So examples of a heterogeneous mixture. Let's say that you went to the beach and you wanted to bring home a beach in a bottle for yourself, right? So you put some sand and some shells and some ocean water into a bottle so that you can take it home and you can shake it up, right? Technically, if you take that bottle and you shake it up, it becomes a mixture, right? But if in that moment I were to take a small sample anywhere within that bottle, would it always be made up of the same thing? Absolutely not, right? Because some of it is sand, some of it is water, and they are not necessarily mixing together. And they're certainly not mixing together in an even way where it would be the same all the way throughout it. So this would be an example of a heterogeneous mixture. You can literally see the different things. Why did I say sand and mixture? Whoops. Sand and water. Sorry. I wrote what I said out loud. Okay. Another example of a heterogeneous mixture is something that you have in your kitchen, right? A salad dressing that people like to have is like oil and vinegar. Yeah. You know that oil and vinegar don't mix, just like oil and water don't mix. So if you have a bottle like that, like you can take it, you can shake it and shake it and shake it, but it still just goes through and you have these little bubbles of oil like sitting on the vinegar. So that would be another example of a heterogeneous mixture. Okay, so that's two examples. And we'll do loads more, of course, later on. Those are just some examples to get you thinking in the right direction. So, when we first made this distinction, we said that everything that is not a mixture is a pure substance, and everything that's a pure substance is not a mixture. So, pure substances have the same composition. It is made up of the exact same thing all the time. And there are two different types of pure substances. One is elements, which I know you've heard of before because I know you've heard of the periodic table of elements before. And elements are things that can't be broken into other substances. Okay, they can't be broken into other substances. I can't break them down into anything else that is particularly meaningful. Okay, so an example of this would just be literally anything on the periodic table. So aluminum, right? Like aluminum foil that you use in your kitchen that's made up of just plain aluminum and it's an element. And I can take a slice, a piece, a microscopic, tiny little piece of that aluminum foil, and it'll always just be aluminum. And that's it. And it'll always be the same throughout. Other examples, notable elements like oxygen on the periodic table or hydrogen, any of those things would work. But there's a way to have a pure substance that is not necessarily an element, um, but it's made up of multiple elements put together, and that's called a compound. Okay, now compounds are made up of a set combination of elements. Okay, so in a compound, no matter what, it will always be the same elements put together in the same ratio. So when I ask you what's a compound, the first one that your brain probably goes to is H2O, right? You've heard of H2O, it's water. But what that H2O is really saying is that no matter where I get my water from, it's always two hydrogens and one oxygen put together, okay? Another notable one is like CO2, like we were talking about with the candle lab, right? You have CO2, carbon dioxide, which is one carbon and two oxygens. So this is also a pure substance, okay? They have the same composition no matter what, okay? It's not a mixture, it just is what it is. So this right here pretty much rounds out our graphic organizer that we're going to do. So we learned about matter. We learned that there are three different states of matter: solid, liquid, gas. We know that matter has mass and it takes up space or volume, and that all matter is either a mixture or a pure substance. If it's a mixture, it can be homogeneous or heterogeneous, and if it's a pure substance, it can either be an element or a compound.